Okay, today is March. No, it's not. It's not May. April. What month are we in? Avery? We're in May. May 18th, 17th. 17th. We have a 4-question warm-up this morning with essential learning for your grade 8 understanding, because if next year when you go into grade 9, if you don't know these ones, you're going to really struggle mightily. So let's make sure we understand how to do this. Our first question is a fraction question that is an order of operations. We have a multiplication and addition. So we know from our experience with BEDMAS we have to do our multiplication first. There are technically 2 ways you could do it. Since you are multiplying it, you could double the 1 and you could double the 3/5, which I think some of you did. Or another way to do it was just convert your mixed fraction into an improper fraction. And when you multiply by a whole number, algorithm-wise or procedural-wise, we can change that whole number to over 1. And once we do it this way, piece of cake, because all we have to do is multiply our numerators to get 16, multiply our denominators to get 5, and that's our answer to the product of 1 and 3/5 and 2. Bring down the rest, keep it where it is. Now that we've written it that way, we're adding 2 fractions together, Deacon, which requires what? It needs a common denominator. The first common denominator 4 and 5 share is the number 20. Once we know that, we make our equivalent fraction of 5/20. What's 16 times 2? Anybody? What's 32 times 2? So 16 times 4 is 64. Once you have that, you add your numerators. 5 plus 64 is 69 over 20, which is 3 and 9/20 as a final answer. Quick show of hands, how many got that right? Good. Let's do 2 points for this question. 1 point for work, 1 point for answer. 1 point for work, 1 point for answer. As long as the work was coherent, you can give them full points. Our second question is an integer question, which has a multiplication, a subtraction, and a multiplication. We have 3 operations here. Of those 3 operations, what will we do first, Nicole? All of our multiplications. So when I think about the first one I'm going to do, I'm actually going to do that question and that question first. Those are our 2 multiplications. And that middle sign of subtraction is going to stay right where it is. So -5 times -2 is a positive 10. And a -3 times a positive 5 is a -15. I'm going to put that in brackets to separate it from my subtraction sign. Now I have a subtraction left. Easiest way to solve it is keep flip change. My answer is positive 25. My next question is a proportional reasoning question or a rate question. The cost is $4.20 for 7 somethings. And the question then says, using proportional reasoning, determine how much 8 will be. How many of you used the multiplication divide, figured out what you multiply 7 by to get 8? Did anyone use that one? I'm just going to see if I can figure it out. What's 8? 8 divided by 7 is a long repeating unforgiving number. So that method isn't going to be what we use here. Oh, shoot. The calibration's off. The method we're going to use here is if we know how much it is for 7, we're going to determine how much is it for 1. What's $4.20 divided by 7? Anybody? Or how much money is that? It's 60 cents for 1. If it's $4.20 for 7, it's 60 cents for 1. And therefore, to figure out how much it is for 8, I'm going to keep my idea of proportionality, multiply it by 8, use my eraser, and I have $4.80 for 8 as my final answer. How many use that method? How many use algebra? If you did use algebra, you knew that, let's go back in time real quick. If you did use algebra, you did this. You multiplied across here to get 7x. You multiplied across here to get $32, $33.60. Is that right? Divided both by 7, and $33.60 divided by, clear, 3360 divided by 7 is, oh, for heaven's sake, clear, abandon ship. What was it again? 3360 divided by 7 equals $4.80. Same answer. And finally, our algebra question. How many steps is this algebra question? 2 steps. And when you have a 2-step algebraic equation, Gavin, what is the easiest thing to get rid of first? And what is your constant in this equation? And how am I going to get rid of it? Correct. We're going to use opposite operation to add 3 to both sides. Can anyone remind me how I read this expression right here, the x over negative 2? What's the proper way of reading that? Calvin? You can read it as x divided by negative 2. That's one way to do it. There's a better way. What's the better way of reading that? A negative half of x, right? Same thing. So a negative half of x equals, what is a negative 8 and a positive 3 combined to make? A negative 5. But if I read it the way Calvin said, x divided by negative 2, the opposite operation of that is multiplying by negative 2. Opposite operations, x will equal a positive 10.